All right, today we're going to be talking about waves. We're just going to review this PowerPoint instead of using my fancy window on my deck. We're just going to go over this PowerPoint and a screen share. So I'm just going to talk about the stuff that you see on each slide. I'm going to talk about some equations. I'm going to talk about waves, talk about parts of waves, and some vocabulary. So if you need to pause and listen to information a couple times, that's just fine. This will be on YouTube, so you can go back and watch as many times as you want or need to. So the first slide, we're just going to talk about wave parts. I'm going to use my mouse to highlight stuff, but there's different parts of the wave, unsurprisingly. The four parts labeled here are the crest, and that's the top of the waves. So waves have multiple crests as they go along. The trough, which is the bottom of the waves, and then you've got the amplitude. Now this is the midline. All right, there's equal parts of the wave both above and below this line, and the amplitude is how far above this neutral position or midline the wave reaches. And then finally is the wavelength. This is the length of one full wave. Now technically a wave starts here, goes up, and then down, and then back to the midline again, and this is one full wave. But it's kind of difficult to measure from here to here, especially if the midline isn't labeled. And so usually wavelength is measured from either crest to crest or from trough to trough. And what you'll find is that this distance here is equal to the distance over here we talked about before. So the easiest way, the most common way to measure wavelength as a result is crest to crest or trough to trough. And so basically what you're looking for is that wave being back at the same position you left it from. So from here all the way down and then all the way back up, or from down here all the way up and then all the way back down, or from midline to midline. Now the thing that could get confusing about that though is right here is a midline, but this is only half of a wave. So we have to measure both the top and the bottom part of the wave. So we can go to the next slide. We're talking about wave energy. Now, to measure the energy of a wave, we look at two things. We look at amplitude and we look at frequency. Now, we talked about amplitude before being how high above the midline the wave goes. Now, the taller the amplitude, the higher the energy, and that makes a lot of sense. But the higher the frequency, now we haven't talked about frequency, but what frequency is how many waves pass a particular point in 1 second, and that's measured in hertz. So if you've heard of the measurement system hertz before, that's how many waves pass a point in 1 second. So the more waves that pass a certain point in 1 second, the higher the energy. So the thing that usually makes a high energy wave is a really short wavelength, because the shorter the wavelength, the more waves are able to pass a particular point per second. So a large amplitude and a large frequency means that a wave has a lot of energy. Now, one other thing that's worth pointing out is that frequency is significantly more important than amplitude when it comes to wave energy. And in fact, when people talk about wave energy, they usually just talk about frequency. They don't talk about amplitude at all. That being said, amplitude is still a part of wave energy. So one thing we're going to look at a fair amount is wave speed. And there's two ways to measure it, all right? One is to take the equation V equals lambda divided by T. So V stands for wave speed, or velocity, just like we've used it in the past. And it is equal to lambda. Now lambda represents wavelengths, which is measured in meters. And then we're going to divide that by period. Now what period is how long it takes one wave to go past a certain point. So if frequency is how many waves pass a point per second, period is kind of the inverse. It's the opposite. It's how long does it take one wave to pass this point. And so period is measured in seconds. So if we take wavelength and divide it by period, meters divided by seconds, we get the speed of that wave in meters per second. So basically the units that we're working with are the same that we've always used for velocity, but we're working with slightly different variables because we're talking about waves. We're not talking about an object traveling past a point. So velocity equals wavelength divided by period. And once again, period is how long does it take one wave to pass a point. Now the other thing we could look at is frequency and velocity. So that brings us to this equation on the right, where velocity is equal to frequency times wavelength. So now we're looking at velocity, which is still going to be measured in meters per second, is equal to frequency, which is measured in hertz. Now remember, that's how many waves pass a point in every second. It's the opposite of period, is the inverse of period. And we're going to multiply that by wavelength. So we have meters per second is equal to hertz times meters. So basically we have these are the same equations, but since period and frequency are inverses of one another, we're looking at multiplication on the right and division on the left. Either equation will work to find wave speed. Realistically, it just depends on the information you're provided with. You're going to be given a wavelength in either scenario, but maybe in one scenario you're provided with period, and so then you'd want to use the equation on the left. Maybe in a different scenario you'll be provided with frequency, and you want to use the equation on the right. Either way, you'll end up with the same answer. So just some general vocabulary for waves. Crests, we talked about that. That's the top of the wave. Trough, that's the bottom of the wave, the low point. We've got the period. We've talked about periods, but we'll talk about it one more time. A period is how long it takes for one wave to pass a point. How long it takes for one wave to pass a point. So it's measured in seconds. It's basically seconds per wave. Wavelength is the length of one wave from crest to crest or from trough to trough, and it's measured in meters. We have frequency, and frequency is the opposite of period. Instead of counting how many seconds it takes one wave to go past, frequency is how many waves go past in 1 second. So once again, we're looking at 1 point, and if we start a stopwatch for 1 second, how many waves pass that point per second? That's measured in hertz. Hertz means waves per second. Amplitude. Amplitude is how far above the midline the wave goes. Now what you'll notice is that most waves, ocean waves are not an example of these, but most waves that are just energy waves through a material, that the amount that the crest is above the midline is equal to the amount that the trough is. So amplitude can be measured either above or below the midline, but usually it's measured above the midline. So how far above the midline or the neutral point does a wave get? And then finally, nodes. So on a standing wave, I'm going to go back, we'll talk about nodes on this slide here. On a standing wave, now what standing waves are waves that look like they are in one spot. And it's just because the frequency is so consistent. But where the wave crosses the midline, these are all nodes. So that's what nodes are, basically, where the wave crosses the midline. So those are the vocabulary words that you're going to need. So what I want you to do at the end of this today is just hop on this website. This will show you the different types of waves. There's not very many. You got your surface waves, you've got longitudinal waves. But hop on there. You can see the different types of waves, and that should do it for today.